Hey everybody, today we're going to go over the k-means clustering algorithm. And it's so nice because it's extremely powerful and extremely easy to understand. We have n data points. Okay, so I'll mark them x1 up to xn. Okay, where they're actually vectors. And so we'll say xi is actually a member of the Rm family, which is basically just saying it's an m-dimensional vector. All of them are m-dimensional vectors, which I hope isn't scary to anyone that I'm saying the word vector. For each of the data points, for each of the xi's, we know exactly m things about each of them. So an example is that we could have xi, so each of them, xi is a person, where its components, so basically where xi is equal to width in centimeters and height in centimeters. All right, so an actual example of what a vector could be is we could have, for example, A is equal to, or A is a vector, is equal to, say, 40, 175. Okay, so we had a person that was 40 centimeters wide and 175 meters tall. We have n of them. All right, we have n people where we know, for example, their width and height. So to explain the k-means clustering algorithm, what its job is to do is actually to assign each of these x1 up to xn. So each of these guys, we want to assign each of these guys to a group. All right, I'm just going to write that down. We want to assign each xi to a group. All right, now a good question would be is how many groups do we have? Well, that's the k. All right, you tell me, how many groups do we have? Okay, how many groups? This is your job. Okay, you should tell me how many groups there are. And now this is really confusing because then you're saying, oh, I have to come up with how many groups there are. Or if you don't know the answer, then try a bunch of them and see what works. Okay, so I'm going to say how many groups. You may or may not know the answer. You may or may not know the answer. Okay, so say for example you did know the answer in this example. That would mean, well, okay, you have n people where we know their width and their height. How many groups would you want to make out of them? Well, let's say there's two groups. Let's say, and I'm hoping not to offend anybody by this video, I'm just having fun with the example. So say for example there is two groups where we have shorter and wider people and we have taller and skinny people. Okay, so I'm going to make an amusing drawing. Hopefully it doesn't offend anybody. Maybe we have two groups, which is like maybe these people. Here's the Santa Clauses. Okay, that's one group, the green group, and the yellow group would be these people. Make them really tall. Okay. Okay, there's my short and wide and my tall and skinny people. Maybe you were going to tell me you were a fitness trainer and you were trying to group these two different people. You had, say, two different fitness plans. One was for short and wide people and one was for tall and skinny people. But say you just wanted to figure out how many groups there were and you wanted to assign people to different groups. You don't really know. You want You want to know how many different fitness plans to make. And to do that, you're going to look at your people, and maybe your algorithm will say, oh, I think there's 4 groups of these people. And what it'll also do is assign each of those people to those 4 groups. And then you could actually make a fitness plan for each of those people. So maybe you do know the answer. Great. If you do, that's fine. You can just set K, or the number of groups, to whatever amount of groups you thought there were. So say you thought there was 2 groups, we'll set it to 2 and then let it run. That's great. If you don't know how many groups there are, you're trying to find that out, well, then we can try various amounts of K, and we can analyze that result to say which is the best one, and we'll assign everybody to one of those, say, 4 groups. If the algorithm thought 4 was the best number of groups, then either way, you're going to know how many groups there are, and each person will be assigned to a group. All right, so hopefully we're clear about the goal. I'm going to go over the algorithm now. All right, I'm just going to clear some of this stuff up. So in this example, we're going to say that we do not know the number of groups, just to keep it interesting. But if you did know the number of groups, then that's fine. It would be very similar, except you wouldn't have to experiment with other numbers of K. But for this, I'm going to show you how it works with many different Ks. Trying to figure out basically how K-means is going to figure out the number of groups that is best. So if we were to plot our data, say that we had width and height, and they are both in centimeters. So I'm not going to show the numbers. I'm just going to plot some data and say that maybe we had this many. We had this many over here, and we had this many over here. Okay, normally your data is not going to be this pretty. I'm going to make a bit of a pretty example just for fun, just to show the idea. So if you did graph this information and it looked like this, well then yes, you'd probably just tell me that there was 2 groups, and you would assign, say, a red group. You would assign each of these to a red group and each of these to a blue group. You could do that by hand. But I'll show you what the K-means algorithm would do if you don't know that 2 is the right amount. Also keep in mind that if you're higher than 2 dimensions, you'll never be able to graph it like this. It won't really make sense. So with that in mind, maybe K-means started with just 1 group. Now this is kind of silly, but I'll show you what it would do. It's going to randomly initialize a mean, say here, and what it does is it assigns all of the points to their closest mean. Well, there's only 1 mean, and so it's basically going to assign everything to the red group. And then the second thing that it does is it moves the group spot to the middle of everything that was assigned to it. And so since everything was the red group, it's just going to move it to the middle of this data, and it's going to be right there. And now we can basically say that all of these points are assigned to the red group. And now I'm going to start this plot over here, one other plot, which is basically going to be some measure of error and the number of groups for K-means. So we did 1 group, and we have a huge error, which is going to be defined as the sum of all the distances between each of the points and the group. And each of these are really far away, like they're so far away from this group. And so we're going to have a huge error. I'm not going to mark the number again, I'm just going to show it relatively, and it's going to be a very high error for 1 group. All right, there's 1 data point. Now let's do it again with 2 groups. So I'm going to randomly initialize a red group and a blue group. So maybe it started with this. And now what it does is it brings each of the points to their closest group. So it's going to maybe assign these blue things, these points as blue, these points as blue, and these points as red. And now what it does is moves each of the means to the middle of their assigned groups. And so red is going to go in the middle of its group here, and blue is going to go in the middle. Well, it's kind of hard to say middle, but it's going to be strongly weighted over here because there's a lot more points in that direction, but it's still going to not be too close to them because the other ones it doesn't want to keep them too far away. So then we get rid of the x's and the groups, and now we're left basically where we started again, except the x's are in a different location. And so This time, we're going to do the exact same thing, as we're going to assign each of the points to their respective closest group. And so all of these would be red, and all of these would be blue. And then it puts the X in the middle. And it erases the previous again. And now the algorithm is going to complete because each of the points are not going to change groups again. If we were ever to try and run the same thing again, all of the previously blue points would be assigned to the blue group, and the previously red points would assign to the same red group. And so this algorithm is done. The points are never going to change groups, and the X's are never going to change locations because of that. So then we can mark another spot on our error, which is going to be a lot better than before, because think, before we had this thing in the middle here. We had this one thing and it was these huge distances, except now we just have these two. And so we're going to have maybe an error that's like, well, significantly better. Actually, we don't really have that much error at all. So it's going to be way down here. All right. And now for reference, I'm going to actually duplicate this picture, and I'm going to do this 2 more times rather quickly now because I think you got the hang of the algorithm. I just want to see the results. So if we were to do it with 3 groups, we would maybe end up with something like this. And I'm going to jump actually straight to the end. Maybe with 3 groups, we got something like this. Well, comparing to our previous one, we still have less error. Let me bring it over here again. Okay, so to get these side by side, here is the 2 versus the 3 groups. And so we definitely have less error with the 3 groups over here. You can see there's a lot less error over there. This one's the same basically, but there's less error here. And so it's not that drastic though, okay? So if we were to append our diagram, we would have something, and sorry, I forgot to label that this was for 2. And for this one, we'd have, a little less. And if we were to do it super quickly again with 4 groups, maybe we actually had something like this. And we'd have a little bit less. And in fact, this pattern would continue. I keep forgetting to write the number of groups for some reason. So for group 1, we had this much error. 2, we had this much error. 3 had this error. 4 had this error. And so it's going to draw a pattern that basically looks something like this. And it does that because as you add more and more groups, obviously you're going to have less error because the points are going to find a closer mean than they were before. Except there's going to be one spot, hopefully, where there's some drastic change. And that we call the elbow point. It's like this is the elbow right here. It dropped a lot. And it's still going to drop afterwards, but it's going to kind of smooth out after that. It drops a lot here, showing that this should be the true number of groups. Okay, and if I was to show that to you, this looks right. We found the 2 groups. We have this diagram. We can assign our points, or they're already assigned to these groups. These are all the red, these are all the blue. It decided 2 things for us. It decided that 2 was the best number of groups, and it decided which points belong to which group. That is the point of k-means. And again, if we knew the number of groups beforehand, if we said, okay, actually I want there to be 2 groups, then we would just set k equal to 2. It would only have to run for that version, and we'd have the points classified into one of these 2 groups. So hopefully that explained the k-means algorithm. Let me know in the comments below what you thought about the video, what I could have improved on, what you liked about the video. Give it a thumbs up if you did like it, and please subscribe to the channel. Over 80% of the people watching these videos aren't subscribed to the channel. So please do us all a favor, hit the subscribe button. I would appreciate it. Thanks so much. I'll see you next time. Bye-bye.